Okay, so here we're going to do some infinite limits. Our first problem is the limit of 5 over x minus 4 as x approaches 4 from the right. Well, think about, first of all, let's look at a number line. 3, 4, 5. So as we approach 4 from the right, coming in approaching 4, our numbers are always a little bit bigger than 4. Yeah? 4.1, 4.01, 4.001. We're always a little bit bigger than 4. When you take, let's say when we approach, when we're right here, let's say that's 4.01. 5 over 4.01 minus 4 is 0.01. Yeah? Now, this is 1/100th. And 5 divided by 1/100th is 5 times the reciprocal of 100 over 1. We end up with 500. Now let's get even closer. Let's say we get x is 4.001. Now we're even closer. 4.001 minus 4 is 0.001. Well, this is 1/1000th. Similar to this, 5 divided by 1/1000th is 5 times 1,000, which is 5,000. Now let's get even closer, 4.00001. Yeah, minus 4 is 0.0001. Tens, hundreds, thousands, this is 1/10,000th. 5 divided by 1/10,000th is 5 times 10,000, which is 50,000. So look at what's happening here. Our numbers are just getting bigger and bigger and bigger. The closer we get to 4, the overall value of that fraction is getting bigger and bigger, and it's positive. In other words, it's going to positive infinity. This is the same idea, but now we're approaching 4 from the left. When we come in from the left, we're always a little bit less than 4, right? 3.9, 3.99, 3.99999, getting closer and closer. It's the idea of a limit. So when we get closer and closer to 4, when we subtract, it's going to get close to 0, but it's going to be negative because x is always a little smaller than 4. And a number smaller than 4 minus 4 is a negative. Just like we saw in the last example, this is getting closer to 0, but it's going to be negative, negative 0.01. Get even closer, negative 0.001, negative 0.0001. And 5 divided by a really small negative number shoots off to negative infinity. Yeah? Just like we did before. Well, now, just like we did in the last section, the last video, the limit from the right is positive infinity. The limit from the left is negative infinity. These are not the same. So the limit of our function as we approach 4 does not exist. So what is this really telling us? And we can tell the graph of this when we're at 4, we're getting this vertical asymptote. As we approach from the right, what's happening? Our graph is going up to infinity. As we approach 4 from the left, our graph is going down to negative infinity. Yeah? And we'll worry about the end behavior later, and that's a different limit, but we'll do that when we discuss horizontal asymptotes. Okay, now what about this problem? What's the limit as we approach 6 of x over x minus 6 squared? Well, when we approach from the right, 5, 6, 7, we're always a little bit bigger than 6. A little bit bigger than 6 minus 6, keep in mind x is getting really close to 6. And when we subtract, it's going to 0. And it's going to be positive because we're always a little bit bigger than 6. And a number a little bigger than 6 minus 6 is going to be positive, but the closer we get, the closer this subtraction, this difference, is going to get to 0. So when we approach 6, the numerator is 6, and the denominator is a really small number squared, which is some other really small number. 6 over a really small positive number is a really big positive number, quantity, whatever. Positive, in other words, it's shooting to positive infinity. Now, this is going to be positive infinity because what happens when we approach 6 from the left? Because keep in mind, from the right it's infinity. Is it infinity from the left? Well, when we approach 6 from the left, we're a little smaller than 6. So when we do this subtraction, we're going to get a small negative number. But when I square a negative, it becomes positive. So this is still approaching 6 because that's what x is going to, so it's getting closer to 6. The denominator is this part is some really small negative number, but when I square it, I get a really small positive number because a negative squared is positive. And 6 over a really small number, that entire quantity is a really big number, i.e. positive infinity. So the limit from the right and the left as we approach 6 is infinity, therefore the limit is infinity. And last, what about this one? Well, we could plug in our numbers here, but when I plug in -2, we're going to get some number over 0. And we don't know, when we divide by 0, we're not sure, is that it's a limit where the denominator is going to 0. And the question is it going to be positive or negative infinity? So what we want to do is factor. So we have the limit as x approaches -2 from the right. This factors to x plus 3, x minus 3. The denominator factors to x minus 3, x plus 2. The x minus 3's cancel, and we're left with the limit as x approaches -2 from the right of x plus 3 over x plus 2. So what is this going to give us? Well, let's analyze this a little bit. So as we're approaching -2, -3, -2, -1, 0, we're approaching -2 from the right. So it's like -1.9, -1.999. So this is approaching -2. -2 plus 3 is 1. And what's happening to the denominator? Well, again, we're coming in from the right. So it's like -1.9, -1.999, -1.99999, getting closer and closer. -1.99999 plus 2 is going to be a small number, but it's going to be positive. So 1 over a really small positive number is a really big positive number, i.e. positive infinity. So this goes, I'm going to put the plus sign, you really don't have to, but that result is going to positive infinity.